Hello and welcome to our PKSim online tutorial series. In this video, we will show you how to create a compound. The drug midazolam will be used as an example. We will explain how to add physico-chemical properties, a metabolizing enzyme, and a renal clearance process. To create a compound, right-click on Compounds in the Building Block Explorer and choose Add Compound. Enter a name for your compound. Type midazolam. In the Basic Physico-Chemistry tab, you can define the physico-chemical properties of your compound. Parameters marked with a red cross are mandatory. These include lipophilicity, fraction unbound, molecular weight, and solubility. They are used to calculate values like intestinal permeability and the partition between red blood cells and plasma. You can rename your entry in each field by using the three dots, or add more parameter values by using the plus symbol. By default, a small molecule is predefined. If you want to model a large molecule, such as an antibody, uncheck the checkbox. The first parameter is lipophilicity, where you can enter a log P value. For our example, midazolam, enter a log P value of 3.1.03. You can add a reference for this value in the value origin box on the right. The second parameter is the plasma fraction unbound, which is used to estimate protein binding. Plasma protein binding to albumin is predefined. You can also choose alpha 1.0 acid glycoprotein or unknown if you do not know the binding partner of your compound. Enter a value of 1.0.6 for fraction unbound and select % as the unit from the drop-down menu. The next parameter is molecular weight. Enter the molecular weight of midazolam, which is 325.77 grams per mole. If your molecule contains halogens, define this in the drop-down menu under Has halogens. Here you can enter the number of chlorine, fluorine, iodine, and bromine atoms in your compound. For midazolam, add 1 chlorine and 1 fluorine. To close this pop-up window, click the cross on the bottom left. Next, you can choose the compound type and pKa values. This means defining whether your compound is neutral, acidic, or basic. When selecting acid or base, you may enter one or more pKa values. For our example, select base and enter a pK value of 6.105. Drug solubility at different pH values can be entered in the lower section. Enter a solubility of 49 mg per liter for midazolam and change the reference pH value to 6.5. Now click Next at the bottom to proceed. The ADME tab will open. Here you can define parameters describing the absorption, distribution, metabolism, and excretion of your drug. You can also add relevant inhibition and induction parameters. In the absorption menu, select specific intestinal permeability. The calculated values depend on log P and molecular weight. Click the plus icon to add a new entry. This is necessary when the specific intestinal permeability needs to be optimized. Name the new entry Optimized and click OK. Enter a value of 1.0.88 times 1.00 to the power of -4. Now proceed to the distribution calculation section. Here you can choose the calculation method. PKSim offers several predefined methods for calculating organ plasma partition coefficients and cellular permeability parameters for barriers between the interstitial and intracellular space. Further details on the calculation methods can be found in the PKSim handbook on the OSP website. Different methods can be selected in the drop-down menu. If you want to optimize organ permeability, you can follow the same steps as for specific intestinal permeability. For midazolam, select the Rogers and Rowland method for calculating partition coefficients. If your compound shows target-mediated drug disposition, you can add the corresponding protein binding partner under Distribution and Protein Binding Partners. Now, to add a metabolizing enzyme, right-click on Metabolizing Enzymes and choose Add Metabolizing Enzyme. A new window opens. Here you can define the metabolizing processes for your compound. In the Metabolizing Enzyme drop-down menu, you can select one of the enzymes already defined in the individual building block. Select CYP3A4. Enter the name of the reference, for example, the name of the publication you are extracting the data from. Choose the process type that matches your data. You can add Michaelis-Menten, first order, or Hill processes. Select the in vitro metabolic rate in the presence of recombinant CYP enzymes using the Michaelis-Menten process type. Enter a kilometer value of 2.73 micromole per liter for midazolam and click OK. In the Transport and Excretion menu, you can add transport proteins, renal clearances, or biliary clearance processes. To add glomerular filtration, which is active under physiological conditions, right-click on renal clearances and select Add Renal Clearance Process. In the new window, select glomerular filtration. A GFR fraction of 1.0 is predefined and represents passive filtration. A value greater than 1.0 indicates active secretion, while a value less than 1.0 means the compound is reabsorbed from the glomerular tubule. Name the process assumed and click OK. Click Next and then click OK. The compound now appears on the left-hand side. If you right-click on the compound, you have several options. You can rename it, clone it to create a copy with the same properties, or delete it. Thanks for watching.